Thanks for joining us. For those who joined us last week in this Twitch deep dive, I'm sorry we couldn't make it, but there's a lot of fun content and a lot of interesting things to talk about with you today, and we'll get right to it. So this deep dive is about serverless architectures, serverless approaches, how to best test your serverless applications, what kind of development tooling or technologies you may be thinking about as you approach serverless, and talk about serverless applications. My name is Salman. I lead the AWS Serverless Application Repository service. We'll talk a little bit about that at the end as well and how it ties together in serverless development. And with me is James, who's the lead developer on the Serverless Application Repository.
Hi, my name is James Hood. I'm a senior software developer for Amazon. I've actually been with the company about 8.5 years now. I've spent some time in Amazon Web Services, spent some time on the retail side, got really excited about serverless, as I know many people are, and ended up coming back to AWS to be tech lead for the serverless application repository. So really happy to be here.
Thanks for doing that. Okay, and we also have this unboxing that we will do at the end. It's you don't know what it is, so it'll be a surprise to you, James. It's a symbolic token of our appreciation and an ode to all the builders out there.
Okay.
But stick around till the end of the show and we'll do this quick unboxing for you.
All right, we'll see.
Move this out. Sorry about that. We were paused for a second. We just had made sure all the audience could join this Twitch deep dive, and I really appreciate you guys joining us. So we'll do a quick recap, James. I don't want to waste anyone's time who has already been with us for the first 8 minutes. The goal of this Twitch deep dive is to talk about serverless architectures and how we think about, or perhaps best practice about serverless approaches. My name is Salman. I lead the Serverless Application Repository service, and with me is James, who leads the engineering for the Serverless Application Repository. How about you quickly introduce yourself to the audience again?
Yeah, my name's James Hood. I'm a senior software developer for Amazon. I've worked in both AWS and retail sides. I'm the tech lead for the Serverless Application Repository and a big serverless apps advocate. I'm very, very excited about them.
Cool. Just as we were talking and catching everyone else who just recently joined, we were talking about serverless patterns, which people are building themselves that sort of lead to a larger architecture that perhaps could be simplified with the application construct that we have now with SAM, and we'll walk people through that a bit. And you were going to dive deep into that. But before we do that, we want to see what the Twitter leaderboard is?
Yes.
And we want to talk about the game real quick with the audience as well?
So right now you and I are dominating with retweets.
Okay.
So for those of you, please don't let us win. Come on. So if you want to play this game, you just need a Twitter account. There's a link in the Twitch chat. If you click on that link, it will take you to a screen where you can tweet a very specific message, get as many people as you can to retweet that message, and meaning get the retweet counts up on your tweet. And then you'll appear on this leaderboard as well. It's updating in real time, and we're checking in on it as we go.
And the reason we're doing this game is not just because I think the game is fun, but because this is backed by a serverless application that James put together pretty rapidly, quickly, and we'll walk through how he did that, something that you guys can learn from. It's almost as if Twitter is an event source now for Lambda.
Exactly.
All right. So we'll get back to that and back to our regular programming on serverless patterns that you are seeing as can be composed as applications. Why don't you walk us through it?
Yeah, so the quick recap is that serverless pushes you toward more of a reactive, event-driven architecture. I was talking about my past experiences where I'd architected systems. My initial serverless architectures were kind of big, Rube Goldberg kind of unwieldy systems. And what I've found is that serverless applications allow you to take pieces of a larger system and compartmentalize them, make them easier to test, and deploy into your application as pieces. So I wanted to talk about one example app that's available in the Serverless Application Repository. It's on the screen. It's called the AWS Serverless SQS Event Source. So why is it called that? Right now, Lambda has a number of native event sources. So S3, you put an object into S3, it can trigger your Lambda function to do something. You write to DynamoDB, and an event can come off of the DynamoDB stream and trigger your Lambda function to do something. One service that is not integrated as a native event source for Lambda is SQS, Simple Queue Service. And so what I've done is I've built an app that turns SQS into an event source.
Interesting.
It's available on the repository. You can deploy it to your account. And now you don't have to worry about managing the interactions between an SQS queue. You can just write a Lambda function that can process messages.
Okay, so let's at least walk me through like why are SQS queues important? Why is the interaction with them important and sort of the modern day approaches to serverless architectures? Maybe give it a real world example for the audience and for myself.
Yeah, absolutely. So in a service or distributed or service-oriented architecture, you end up with many different services, and to fulfill one request, you may need to interact with multiple. And the initial approach is kind of a fully synchronous approach. And what I mean by that is when a request comes in to create an order, for example, then behind the scenes, you may need to call the order service and the customer service and some shopping cart session service and make all these calls. If you call all of these things synchronously and block on them before responding to that request, it has a number of problems, right? There are a number of problems with that approach. You can get higher latencies, and then if any one component in that system is having issues, then it affects the customer experience.
It's almost as if like, hey, I've placed the order, I have to wait for it to ship to me for me to get a response back from you. We don't want that experience. We want the customers to know that we've got your order and we're now going to make the changes in our system to make sure that you get the order in time that you can track. So queuing is a mechanism to do that.
Yeah, so in a distributed system, queues act as a buffer, an asynchronous buffer between all these services, which allows them to be more fault tolerant. And it does transform the processing into more of an asynchronous model from a synchronous.
Got it. And so what are you going to demo today for us? We talked about the AWS application that enables you to sort of think about emulating SQS as an event source.
Yeah.
Are you going to walk through the architecture?
So I'll show you really quick. The app is actually quite simple. So let me zoom this in a little bit.
Yeah.
So this picture depicts the app. What's in the dotted line is the app. We have a CloudWatch events rule. You can think of that kind of like a distributed or cloud-based cron, right? You can set up something to happen at a regular interval or at some cron-based time or schedule. So this can trigger your Lambda at a particular rate. So this app contains a Lambda that gets triggered every minute, and then that Lambda, so apps allow you to pass in parameters to the app. So I've parameterized the SQS queue and your Lambda that's the message processor, right, for this. So this app polls on a regular schedule, polls your SQS queue for messages, and any messages it finds, it will invoke your function that you gave. And then your function, depending on the result, you either succeeded, in which case this will delete the message or hack it from the queue, or you failed or need to retry, and it can interact with the queue to make that happen as well. So now your Lambda function no longer has to understand queues or the protocol interactions for SQS. Your Lambda function just processes the messages and returns success or failure.
I think that's cool. So in the box you see just the processor of the SQS queue, both getting stuff from it and putting back into it, and something that handles the business logic.
Right.
So with that, now I have to write less code because the application's there.
Exactly.
Okay, so let's
and another nice thing about it too, so as you'll see when we dive into the code, I chose to write these apps in Java, for example. However, the nice thing about Lambda as an extension point is that your Lambda, even if you're using this app, your Lambda can be written in whatever language AWS Lambda supports. So it's very cool because with these apps we can have multiple languages, but they interact together seamlessly through the
contract and the message that they establish with each other.
Exactly.
You know what? I want to see how. So now I think I understand what this app means. Why don't you perhaps take me and the audience through like what does it mean to use this app, what is inside this app, perhaps look at the code with some testing and walk us through that. I think I'm super curious now.
So to use this app, you really just have to deploy and configure it. So it's quite nice. In the repository, you don't have to worry about where the code's stored or anything like that. You have a link to the GitHub repository. You can take a look. You can take a look through the code if you want. And then when you decide you want to deploy this, you just click deploy. It drops you straight into the Lambda console. You can see the exact GitHub tag that this code's associated with. You can see what specific permissions are required for this app. You can even look at what's called the SAM template, which lays out which resources are in this app. You can look at license information, and then you just need to configure whatever parameters are involved. And like I said, you have this message processor function name. So you just give, and the nice thing is the README is right here. So you can walk through, it tells you installation steps, it tells you what needs to go in which parameters. So really you're just putting, this is the function I want you to call, this is the queue that you're reading.
And these are orange, and so actually, let me just step back a second. So
Yeah.
we have permissions, and we have the SAM template. Let's walk perhaps the audience who may not be familiar with SAM, and what is it, and how can they use it, and then talk about permissions real quick.
Yeah, so SAM is the Serverless Application Model. It's a spec for describing a serverless application in terms of not the code, but in terms of what resources are required and how it's laid out.
Okay, let's look at the example for this one, yeah.
Yeah, let's take a look, for example, at, I know this is small, I'll make it bigger. So here is some code for the SQS event source app. There's a file in here called app.template, and this is SAM. So SAM is a CloudFormation transform, and where I define the parameters.
Yeah. So this is the SQSQ and the Lambda function ARN that someone has to pass into your application, correct?
Function name, and then
function name, sorry.
Yep, and then you can see this resource. I'm defining a serverless function. This is my polar function from that picture.
Got it.
What kind of permissions it has, and then in my local code, I have where to get the code. The nice thing with the repository is you don't even have to worry about that at deploy time.
Right, so when someone publishes an application, the code that they publish with that application is copied over. They don't have to manage that process, and then when someone consumes that application, we make that code available to the deployment process.
Exactly.
Okay.
And then events is what triggers this Lambda function. So SAM provides a nice convenience layer that allows you to, this one is on a timer at a particular schedule. In this case, it's a rate of every 1 minute.
Got it.
Okay, so this is your SAM template. You can also review it. If I go back to this screen, you can review the template before you're deploying it into your account.
So you can understand perhaps how the application is laid out, what resources it would create, and et cetera.
Exactly.
Okay.
You fill in your parameters, you click deploy, and then it deploys. I'll just, so this won't actually work because I'm just putting whatever in here.
Sure.
But
do you have a copy of it that has already been deployed into your account?
with the SQS one, I don't have one ready for today, but I do with the next app that I was
the
going to
Twitter
show.
one, yes, that's what you're going to demo.
Yeah.
Totally.
But we'll at least show getting kicked off, or this kicking off.
So now we've deployed the application, the resources are being created, which interact in.
Yeah, and if you want more details, you can look. It's using CloudFormation under the covers to deploy it. So you can always click on this and see more details about your deployment.
Okay, so we go from I want to be able to read and write to SQS to be able to find an application that does it, to simply deploying it in my AWS account and having that Lambda or set of Lambda functions, whatever that is, because SAM can define more than one, available to me to hook up to my SQSQ and the processor of it.
Yeah, and one reason that I am excited about this, so AWS has a lot of people know that AWS has a very fast pace of innovation, and the number of features and services we deploy is very rapid. But what I'm so excited about with apps is that you don't even have to wait for that, right? So SQS isn't an event source, so we can build an app that does that. And you can do that with other things. Now, this next app I wanted to show, which actually, let's check in on our leaderboard. Oh, there we go.
Leaderboard going.
There we go.
Hold on a second.
Wait,
what?
So I promise I did not put if my username, then make it first place.
See, I don't believe this.
I did not do that.
Reset the leaderboard and let me go retweeting right now. What's going on here? Paul Johnson, I know that guy. Okay, cool.
Yeah, and if you so right now we have more people participating. Thank you so much for participating. Very cool. Angel Romero, Paul Johnston. I'm still at the top. Somebody really needs to boot me from the top, though.
Yeah, you've got your whole family retweeting this right now. So this application is another Lambda, a serverless application built with Lambda and other serverless services that we have. Walk us through this. This is pretty interesting. So now Twitter is like an event source.
Yeah, so what I wanted to show was, this is SQS as an event source. AWS has native event sources, but what about an event source that we probably wouldn't launch as a first-party feature? So this is the AWS serverless Twitter event source. And this is very similar to the SQS event source in that we have a polling schedule.
Got it.
And what it does is it converts a Twitter search into an event source for your Lambda.
So like a Twitter search API?
So Twitter has a standard search API that they make publicly available.
Got it.
And anybody can sign up to use it. And what this app does is it periodically runs whatever search term. Again, you have parameters you can put into the app. So one of the parameters is, what do you want to search?
I see.
Right? And so it will periodically search Twitter, and then the JSON for the tweets is what's returned, and that list of returned tweets gets passed to whatever Lambda function you give the app. So now Twitter is an event source,
So
right?
I think let's just get to code and let's actually look at how this whole thing works.
Yeah,
Because
absolutely.
we've already seen the deployment of an application, so I think that part we've shown. I want to understand, like, how does actual code work for this, and what
Sure. And again, I built this app in Java. You could build it in whatever language that is supported by AWS Lambda. And most importantly, to use this app, it doesn't mean you're locked into Java. You can write your tweet processor in whatever language you'd like.
Okay.
Right. And so let's go find our Twitter event source. Okay. So first off, I want to take a step back because sometimes working in a new domain like serverless, you just want to even know, how do I even lay out my package, right?
Yeah.
So this is Java. What you'll see is it's a standard Maven layout. So I have a POM XML where I can pull in all my Maven dependencies that I need, my libraries. And then I have my main Java code right here. Now, what's a little interesting, so some best practices around using Lambda, we tried to minimize the number of big, heavy frameworks that we use usually, and just want to keep it minimal. So it's very common. So here's my Lambda request handler, and what you'll notice about it is that there's very little code in it. So request handler, this is provided by AWS. There's a package that provides these models.
It's an interface.
Yeah, this is the scheduled event. This is basically a Java representation of what you'll receive from CloudWatch events.
Got it.
Right? So this is what triggers. And what you'll see here is I'm using Dagger. So Dagger is a library that allows you to do dependency injection. So
for initialization of your sort of the application, what parameters it needs, and how to sort of hook things up together.
Exactly.
Okay.
So it takes care of it's a kind of a best practice to separate out all that initialization logic from the actual business logic itself.
Right. So don't put it in the handle request method, take it out, because Lambda goes through two stages, one's initialization and one the other's. So what are the benefits of that?
Exactly. So Lambda has, when the very first time your Lambda is invoked, it goes through a process that's called cold start. So cold start, your Lambda is initialized. So the code you have is downloaded, and then this initializer, which in Java is your default constructor, is invoked. So any common setup that you want to do is done there.
Got it.
Then there's a handle request method, and again, in Python, you can define a request handler method, and that's your request handler, and anything outside it that's statically initialized is what's initialized.
So I see you haven't put any code in the handle request besides this one line.
Right.
Walk us through what's happening here.
Yeah, absolutely. So again, I'm using Dagger to do all the initialization for me, and we can dive into that, but let's just take a look at the poller. The poller is a class called Twitter Search Poller. And when you look, it's receiving on construction the query text that you're going to search, the Twitter client, and various other things that are needed. The poll method, there's kind of two modes that this can work in. It can be stateful, where it remembers what tweets it's seen before, or it can just, like for example, for our leaderboard, which we should check real quick. All right, thank you. Angel Romero knocked me out of the lead.
Can someone retweet my stuff too? I want to be on the top 3.
Don't retweet it.
No. Okay.
And just FYI, we don't have this case now, but if there are ties in retweets, it uses favorites as the tiebreaker. So yeah, great. Loved seeing this activity.
All right, so let's walk through. So we're not going to go walk through the stream portion of it. It's just
Right.
a one full swoop of call the API from Twitter and then do what?
Yeah, so this says find the tweets,
Yeah.
right? And then call the tweet processor for all the raw JSON values that have come back for this tweet.
This is where you sort of set up the leaderboard?
No, actually, so that's the interesting thing. Let me take you out, because the leaderboard is not part of the Twitter event source app.
Oh, so this is just reading from Twitter to get something that you have configured it to do.
Right, so it polls, you give it a search, it polls Twitter for that search, and then it invokes your Lambda function to do whatever with those tweets.
Interesting.
So what's powerful about this is it's generic. It's a generic component. I want to be able to receive tweets and do something with them.
Okay.
That's all this app cares about.
Interesting.
What you're talking about, there's another app that I built that relies on that app. It's called the Retweet Leaderboard. So this is the actual leaderboard that we're populating. So you can see in the architecture, and again, this is published to the Serverless Application Repository. So all these apps are available, publicly available on the Serverless Application Repository. There are full instructions in this README on how to install it and how to essentially recreate this game if you want to. So it's a fun way to get into serverless, experiment around with it. You can see the code along with it. So let's talk about this architecture. So you can see that it's relying on this event source, this Twitter event source.
I see.
And then this app, so the tweet processor, it receives these tweets.
I see.
And then it counts up the retweet counts, right?
I see.
It maintains that count and it writes it to a DynamoDB table.
Got it.
And I'll show you in the console. I'll show you what it looks like.
Okay.
And then this app has an API gateway endpoint.
This is the Retweet Leaderboard app, not the Twitter as an event source app.
Right,
Okay.
exactly.
Okay.
So then we have an API where we can get the current leaderboard value.
Oh, I see.
And it reads, so this asynchronous process is receiving tweets in the background. It's updating this leaderboard. And then this is where the UI that we have calls this endpoint, and then it fetches the current leaderboard.
Oh.
And if you look at this UI, it's actually just a local file I have running on my browser.
Oh, just hitting an API gateway endpoint?
Exactly.
I
It's
see.
asynchronously every couple seconds. It's hitting, oh, I'm at the top again. Uh-oh.
You got more
Angel,
favorites.
get more favorites. Get more favorites.
Hey, where am I? I'm number 4. All right, that's fine. That's fine.
Awesome. I love seeing the engagement. I think right now it's just displaying the top 10.
Yeah, I think that's probably what it is.
Yeah, it's actually adjustable. I could change it. So, well, maybe at the end we'll do that for
Yeah,
fun.
let's do that. So we've got these two applications. One is the event source, one is the processor. How do we monitor these applications? Like, how do we go about, like, actually, I think maybe for the audience to cover back the code part, do we want to go really quickly and walk them to the event source for the Twitter, and what does that actual poll method look like? Just to make sure that everyone's aware, like,
Yeah, absolutely.
how much effort was it to really say, I want to get something from Twitter and invoke a Lambda function?
Okay, so that's something that I actually tweeted about this that is kind of mind-blowing for me. So I actually got this idea for the leaderboard, this whole leaderboard experience, and the Twitter event source app. I was able to write that in probably 1 to 2 day time frame.
Okay.
And then I got the idea for the leaderboard, and we were supposed to do this live stream last week, right? So it was supposed to be last Thursday. I got the idea on Wednesday morning. I went, oh, this would be so fun. And I wrote it that day. So, I mean, it's pretty exciting what you can do with serverless, really, when you don't have to worry about all the extra infrastructure management and can just host it.
Okay, cool. So let's walk through this method real quick, this poll method real quick, and see what we're doing.
So this is the Twitter event source. So this is part of the stream mode enabled, where it's really just saving a timestamp. So it'll either start from the oldest time possible, or it saves a local checkpoint to a Dynamo. So this is if you want to, if you're trying to analyze things in your tweets that are static, that are never going to change, things like the text itself, right? You can use this to save yourself.
It's a feature of an application. You can disable it
just
via
a feature.
Parameter?
Yep, yeah, it's just true-false parameter.
Okay, we'll walk through the audience of that as well. Let's go through the logic real quick.
Yeah, so what happens, so let's just kind of ignore stream mode right now. So if we're not in stream mode, then we're always going to look for tweets since epoch time. So that's every tweet. And what we do is we find the tweets since the cutoff time, which in our case is epoch, so it'll just be all of them. And what this method is doing is it's forming a query. This is provided by the Twitter for J library.
Got it.
And then I'm setting my limit to a high limit. So I want to fetch as many as 100 records per page. And then this is a do while loop because it's a paginated API. You might have to page through many results. So I have my logging here, which I can show you where this shows up in CloudWatch logs. And then this is the Twitter for J library that I'm using. And I do a search for this query. And remember, that query is just populated from your search text. If you want to see, let me finish going through this, and then I'll show where this stuff gets populated.
Sure.
So we search Twitter, we get our results. Now, this Twitter for J library actually pulls those results. It actually returns them as Java objects, but I just want the raw JSON. So I'm first off filtering out the tweets that aren't within my cutoff. Again, with stream mode disabled, I get them all. And then for each of these tweets, I actually populate a list of the raw JSON for that tweet. And Twitter for J has a way to fetch the raw JSON that was returned. So I'm just populating this linked hash map with the tweets and their raw JSON. And that's what gets returned out of here.
Got it. So call the Twitter API, get the search results in raw JSON, create a list of it, and then pass that back to the method above. Okay. So now you have this Twitter.
I have the tweets as raw JSON.
Raw JSON.
If they're empty, then I just fast return. But if I have them, then I have this tweet processor object, and this is really just a proxy. So I'm passing my raw values as a list into the tweet processor.
Okay.
And let's take a look at that logic.
And the tweet processor is being configured at time of application configuration, or?
Yeah. So yes, it is. It's again, it receives the tweet processor function name. This is basically just a proxy for your Lambda function.
Got it. So got it. So you get the list of results. You have a proxy which is going to call the actual Lambda function eventually.
Right.
Right. Got it.
Yeah, and so it's a consumer. So what it does is this allows you may have gotten hundreds and hundreds of tweet results back from the Twitter API, but you only want your Lambda function to be called with a batch of some size. So that's what this is doing. It's partitioning it based on the batch size that you configured.
Got it.
And it's partitioning it into separate lists, and for each batch of tweets, it's saying process batch, which just turns them into a JSON array, and this is the Lambda invoke. So it's invoking
the Lambda you had configured that will actually do whatever it needs to do with this raw JSON in the batch form that it gets.
Yeah, you don't care this app does not care what it does. This app is actually, it's using this invocation type called event, which means that the AWS Lambda service, when you invoke it, it'll just return to you immediately saying,
we'll take care of it.
I got it. It's been queued. That Lambda will be invoked at some point asynchronously.
Cool. All right. So this was a lot to cover. Recapping as I think I've understood it, we have this Twitter event source, and we have a bunch of parameters for this application as defined in the SAM template, which enable me to sort of think about like what search queries to search on Twitter for. And this runs at every minute based on a CloudWatch event trigger that triggers this Lambda function. It captures a list of Twitter tweets, I guess. Tweets. Sorry, that's probably the right way to describe it. And then process it through a proxy to a Lambda function and then do processing on it. And I can attach any type of Lambda function and do whatever I need to do with it.
Any language, any type of Lambda.
Cool. And so now we have this application available in the Serverless Application repository, available on GitHub with the source code, and then the other that actually creates a Twitter leaderboard.
Yeah, which is just one application of it. Cool. So there's two things that I'm hoping that our audience can take away from this. One is if you have an application that needs to do things with tweets, maybe you can use this app.
Or even update it. Send pull requests.
Absolutely. It's all open source. You can update the app yourself, send pull requests in. The other thing is I wanted to show the potential, right? This is a whole category of apps that can be created. Twitter is one event source, but how many others are there? what other applications can you build that will help the entire community, and now we'll have this whole family, this whole suite of event sources that we can tie into our apps.
I think that's I think that's cool and hopefully powerful. So I think we're coming close to our Twitch deep dive at the end portion of it. I do want to do the unboxing of the thing that we talked about early on, but let's recap for the audience. So we looked at serverless approaches. We talked through perhaps architectures and how distributed systems work and how you want to decompose them and only work on certain slices. And we demonstrated, at least with the SQS event source application, that how you could have pieces of the architecture put in place, not necessarily by you writing the code, but them being available in the AWS Serverless Application Repository, and you're just writing your business logic. We also have the Twitter event source we just covered, and the Twitter leaderboard application, both available in the application repository and on GitHub for source code.
Yep.
Cool. I think
Give it a star.
Whoa, shameless
Only
plug.
if you want to.
Shameless plug. But hold on, before we leave the audience and go, let's look at the leaderboard and see who won
Let's take a look.
contest that we had.
No, me. Well, let's just assume I was just demoing. So
James had his entire family and cousins and friends from all over the world retweet it.
I promise, I have the code right here. There's no if JLH
I
code
do not
here.
believe it. No, I really appreciate you guys. Sorry, go ahead.
Angel Romero. And
Angel Romero.
at the top.
And
We'll just discount me at
Yes.
the top. Tomer.
So if you discount you, I'm number 3.
And then you're number 3.
I'll take
how
it.
about I discount you as well?
Thank you. You do that on a daily basis.
That's right.
Okay, cool. So we'll before we leave, we had a small token, a symbolic token of appreciation for an ode to builders. James, you don't know what this is.
Yeah.
We're going to unbox this now, and actually we're not. James, you will.
What?
Yeah, to
All
unbox this and what
Right
do we
now?
have? Yeah, right now, right
Okay.
this second.
All right. So let's see what this is. All right.
I'll help you with it.
Yeah. All right.
We're having technical difficulties.
Let's see.
Pull it out.
Oh wait. There we go.
There we go. Whoa! What do we have?
It's Lambda Builder's hat. It's
Lambda
serverless-
Builder hat.
Serverless Builder's hat.
All right, we shall all wear it.
Yeah.
Put the hat on, man.
Well, I think this is, what did the box say?
Wait,
I think this is for,
this is
for our
oh
audience.
yeah, this is
So
for the audience. I
this
got
is
one. I got one for you.
this-
Yeah,
where?
right there,
Oh,
right there.
Oh, yes.
Ode to all builders.
All right, we're serverless
Keep on
builders.
building serverless.
And we hope that after seeing this, that you are a serverless builder as well.
Yes, and hope to see apps from you that it can help the community build and go do more serverless fun stuff. And catch us on Twitter if you have any additional questions. We both are on Twitter. Our Twitter handles are actually on the Retweet Leaderboard. And appreciate it. Thank you so much.
Yeah, thank you.